Okay, so once again, good morning everyone, and long time no see, no? So our topic for today is all about managing projects, no? That is also another, actually, one subject, no, in fourth year, I think, no, that is project management. So I think the presenter will shorten, no, the discussion or summarize the discussion, because as I mentioned, this topic is one subject or one course in BSCS or BSIS. Now, there is very high failure rate among information system projects. So in nearly every organizations, information system projects take much more time and money to implement than originally anticipated, or the completed system does not work properly. So when an information system does not meet expectations or cost too much to develop, companies may not realize any benefit from their information system investment, and the system may not be able to solve the problems for which it was intended. So the development of a new system must be carefully managed and orchestrated. And the way a project is executed is likely to be the most important factor influencing its outcome. That's why it's essential to have some knowledge about managing information system projects and the reason why they succeed or fail. So in this topic, no, we are looking forward to answer the following questions. No? What are the objectives of project management and why is it so essential in developing information systems? Number two, what methods can be used for selecting and evaluating information systems project and aligning them with the firm's business goals? Number three, how can firms assess the business value of information system projects? Number four, what are the principal risk factors in information system projects? And number five, what strategies are useful for managing project risk and system implementation? Same as what you did at present in your capstone, in your thesis now. It is very important for us to understand the firm. Let's say, for example, if you are now crafting or developing a software intended for Cainta Catholic College, it is very important to us to understand the details on how they will be able to do with it using manual system. Then through that manual system, we will be able to propose a new one. And we need to consider, of course, the connectivity of every department. What are the transactions which is also applicable in other departments? Let's say, for example, enrollment. Enrollment system, how we'll be able to link or to communicate this enrollment system in the accounting office, in the financial, or even in a registrar, or even in a guidance office, and so on. So there are certain, that's why in a database, we discussed it already about databases now. It is important for us to understand the primary key of our databases. So therefore, it is important for us to develop the ERD, the entity relationship diagram, when it comes to database manipulations. How about the restrictions? How about, let's say, for example, how about the user's level? Let's say, for example, I am the registrars and I'm using your system. So what will be the exact, systems, or what will be the exact transactions that I could able to manipulate with this system if my account is a registrar? How about if I am the MIS head? Is there any restrictions? And how about the validation? It is also important to consider the validation. So I think I have a lot of things to share with this, because I really love project management, at the same time capstone project and research. But for us to give more details or idea related to the managing project, let us all welcome our first presenter for this morning. Take it away, Miss Misty.
Good morning po. I'm going to report about managing projects. So, hello po, naririnig niyo po ba?
Yes.
Naririnig niyo po?
Yes, go ahead.
So, what is project management? Project management refers to the application of knowledge, skills, tools, and techniques to achieve specific targets within specified budget and time constraints. So it also involves the planning and organization of a company's resources to move a specific task, event, or duty towards completion. So the importance of project management. It helps every part of the business run more smoothly. It allows your team to focus on the work that matters, free from the distractions caused by tasks going off track or budget spinning out of control. When an information system does not meet expectations or cost too much to develop, companies may not realize any benefit from their information system investment, and the system may not be able to solve the problems for which it was intended. The development of a new system must be carefully managed and orchestrated, and the way a project is executed is likely to be the most important factor influencing its outcome. That's why it's essential to have some knowledge about managing information system projects and the reason why they succeed or fail. So, what is runaway project and system failure? Ito yung mga projects na hindi tapos. Ganun. Tapos, so, sabi dito, on average, private sector's projects are underestimated by one half in terms of budget and time required to deliver the complete system promised in the system plan. So, many projects are delivered with missing functionality. So sabi dito, the Standish Group Consultancy, which monitors IT project success rate, found that only 29% of technology investments were completed on time, on budget, and with all features and functions originally specified. A 2007 Tata Consultancy Services study of IT effectiveness reported similar findings. Between 30 and 40% of all software projects are runaway projects that far exceeded the original schedule and budget projection and failed to perform as originally specified. The system, the, so ito yung consequences ng poor project management. As illustrated in this figure, a system development project without proper management will most likely suffer these consequences. Cost overruns, time slippage, technical shortfalls impairing performance, failure to obtain anticipated benefits. The systems produced by failed information projects are often not used in the way they were intended, or they are not used at all. Users often have to develop parallel manual systems to make the system work. The actual design of the system may fail to capture essential business requirements or improve organizational performance. Information may not be provided quickly enough to be helpful. It may be in a format that is impossible to digest by and use, or it may represent the wrong pieces of data. So without project management, a systems development project takes longer to complete and most often exceed the allocated budget, sumusobra sa budget. Ganun. The resulting information system most likely is technical inferior and may not able to demonstrate any benefits to the organization. Project management objectives. So what is project? Project is a planned series of related activities for achieving a specific business objective. So project management refers to the application of knowledge, skills, tools, and techniques to achieve specific targets within specified budget and time constraints. So information system projects include the development of new information systems, enhancement of existing systems, or upgrade or replacement of the firm's information technology infrastructure. So what are the 5 major variables of project management for information systems? So number 1 is scope. Scope defines what work is or is not included in the project. Time is amount is the amount of time required to complete the project. Cost is based on the time to complete a project multiplied by the cost of human resources required to complete the project. Quality is an indicator of how well end result of a project satisfies the objective specified by management. So the last is risk. Risk refers to potential problems that would threaten the success of a project. So selecting projects. Companies typically are presented with many different projects for solving problems and improving performance. There are far more ideas for system projects than there are resources. Firms will need to select from this group and the projects that promise the greatest benefits to the business. Obviously, the firm's overall business strategy should drive project selection. Management structure for information system. This figure shows the elements of management structure for information system projects in a large corporation. It helps ensures that the most important projects are given priority. At the apex of this structure is the Corporate Strategic Planning Group and the Information System Steering Committee. The Corporate Strategic Planning Group is responsible for developing the firm's strategic plan, which may require the development of new systems. The Information System Steering Committee is the senior management group with responsibility for system development and operations. It is composed of department heads from both end user and information systems area. The steering committee reviews and approves plans for systems in all divisions, seeks to coordinate and integrate systems, and occasionally becomes involved in selecting specific information systems projects. The project the project team is supervised by a project management group composed of information system manager and end user managers, responsible for overseeing several specific information systems projects. The project team is directly responsible for the individual system project. It consists of system analysis, specialists from the relevant end user business area, application programmers, and perhaps database specialists. The mixed skills and the size of the project team depend on the specific nature of the system solution. Linking system projects to the business plan. In order to identify the information system project that will deliver the most business value, organization needs to develop an information system plan that supports their overall business plan and in which strategic systems are incorporated into top-level planning. The plan serves as a roadmap indicating the direction of system development, the rationale, the current systems or situation, new developments to consider, the management strategy, the implementation plan, and the budget. Critical success factors. The strategic analysis or critical success factor approach argues that an organization's information requirements are determined by a small number of critical success factors or CSFs of managers. If this goal can be attained, success of the firm or organization is assured. So CSFs are shaped by the industry, the firm, the manager, and the broader environment. For example, CSFs for the automobile industry might include styling, quality, and cost to meet the goals of increasing market share and raising profits. Your information system should focus on providing information that helps the firm meet these goals. So, ayun, ito po siya. The principal method used in CSF analysis is personal interviews, 3 or 4 with a number of top managers identifying their goals and the resulting CSF. Only top managers are interviewed, and the questions focus on small number of CSFs rather than requiring a broad inquiry into what information is used in the organization. So the CSF approach relies on interview with key managers and then identify their CSFs. Individual CSFs are aggregated to develop CSFs for the entire firm. Systems can be built to deliver information on the CSF. Portfolio analysis. Portfolio analysis can be used to evaluate alternative system projects. Portfolio analysis inventories all of the organization's information system projects and assets, including infrastructure, outsourcing, contracts, and licenses. The portfolio of information system investment can be described as having a certain profile of risk and benefits to the firm similar to financial portfolio. Companies should examine their portfolio of projects in terms of potential benefits and likely risks. Certain kinds of projects should be avoided altogether and others develop rapidly. There is no ideal mix. Companies in different industries have different profiles. Scoring model. A scoring model is useful for selecting projects where many criteria must be considered. It assigns weights on various features of a system and then calculates the weighted total. So, this table shows that this particular company attaches the most importance to capabilities for sales and processing, and sales order and processing, inventory management, and warehousing. The second column in this table lists the weights that decision makers attach to decision criteria. Column 3 and 5 show the percentage of requirements for each function that each alternative ERP system can provide. Each vendor score can be calculated by multiplying the percentage of requirements met for each function by the weight attached to that function. ERP system B has the highest total score. Establishing the business value of information systems. Even if a system project supports a firm's strategic goals and meets users' information requirements, it needs to be a good investment for the firm. The value of systems from a financial perspective essentially revolves around the issue of return on invested capital. Information system cost and benefits. So, tangible benefits can be quantified and assigned a monetary value. Intangible benefits such as more efficient customer service or enhanced decision making cannot be immediately quantified but may lead to quantifiable gains in the long run. Capital budgeting for information systems. So what is capital budgeting? Capital budgeting models are one of the several techniques used to measure the value of investing in long-term capital investment projects. Capital budgeting methods rely on measures of cash flows into and out of the firm. Capital projects generate those cash flows. Rail option pricing models. Rail option pricing models or ROPM use the concept of option evaluation borrowed from the financial industry. ROPMs give managers the flexibility to stage their IT investment or test the waters with small pilot projects or prototypes to gain more knowledge about the risk of project before investing in the entire implementation. An option is essentially the right, but not the obligation, to act some future date. A typical call option, for instance, is a financial option in which a person buys the right to purchase underlying assets at a fixed price or before a given date. Limitations of financial models. The traditional focus of on the financial and technical aspects of an information system tends to overlook the social and organizational dimensions of information system that may affect the true cost and benefit of the investment. So managing project risk. In this chapter, we describe the specific risks to information systems project and show what can be done to manage them effectively. Dimension of project risk. Systems differ dramatically in their size, scope, level of complexity, and organizational and technical components. Some systems development projects are more likely to create the problems we have described earlier to suffer delays because they carry much of a higher level of risk than others. So the level of project risk is influenced by project size, project structure, and the level of technical expertise of the information system staff and project team. Project size. The larger the project, as indicated by the dollar spent, size of implementation staff, the time allocated for implementation, and the number of organizational units affected, the greater the risk. Project structure. Some projects are more highly structured than others. Their requirements are clear and straightforward, so outputs and processes can be easily defined. Experience with technology. The project risk rises if the project team and the information system staff lack the required technical expertise. Change management and the concept of implementation. Successful system building requires careful change management. The introduction or alteration of an information system has a powerful behavioral and organizational impact. Changes in the way that information is defined, accessed, and used to manage the organization's resource often lead to new distribution of authority and power. The concept of implementation. Implementation refers to all organizational activities working towards the adoption, management, or routinizing of an innovation, such as new information system. In the implementation process, the system analysis is a change agent. The role of end users. User participation in the design and operation of information systems has several positive results. Incorporating user knowledge and expertise leads to better solutions. Users and information system specialists tend to have different backgrounds, interests, and priorities. This is referred to as the user-designer communication gap. So, user-designer communication gap. Ito yung gap nila eh, yung user's concern and designer's concern. Systems development projects runs a very high risk of failure when there is a pronounced gap between users and technical specialists, and when these groups continue to pursue different goals. Under such conditions, users are often driven away from the project because they cannot comprehend what the technicians are saying. Hindi nila naiintindihan kung ano yung sinasabi ng technicians. Users conclude that the entire project is best left in the hands of the information specialist alone. Management support and commitment. Management backing ensures that a systems project receives sufficient funding and resources to be successful. All the changes in work habits and procedures and any organizational realignments associated with the new system depend on management backing. Change management challenges for business process engineering, enterprise applications, and mergers and acquisitions. A number of studies have indicated that 70% of all business process engineering projects fail to deliver promised benefits. Many enterprise applications and re-engineering projects have been undermined by poor implementation and change management practices that failed to address employees' concerns about change. Projects related to mergers and acquisitions have a similar failure rate. Mergers and acquisitions are deeply affected by the organizational characteristics of the merging companies as well as by their IT infrastructures. Controlling risk factors. The first step in managing project risk involves identifying the nature and level of risk confronting the project. Implementers can then handle each project with the tools and risk management approaches geared to its level of risk. Managing technical complexity. Projects with challenging and complex technology for users to master benefits from internal integration tools. They must be able to anticipate problems and develop smooth working relationships among a predominantly technical team. Formal planning and control tools. Large project benefits from appropriate use of formal planning tools and formal control tools for documenting and monitoring project plans. The two most commonly used methods for documenting project plans are Gantt chart and PERT chart. So a Gantt chart is a list of projects, activities, and their corresponding start and completion dates. The Gantt chart is in this figure shows the tasks, person days, and initials of each responsible person, as well as the start and finish dates of each task. The resource summary provides a good manager with the total person days for each month and for each person working on the project to manage the project successfully. The project described here is data administration project. So the per chart list is the specific activities that make up a project and the activities that must be completed before a specific activity can start. Increasing user involvement and overcoming user resistance. Projects with relatively little structure and many undefined requirements must involve users fully at all stages. Users must be mobilized to support one of many possible design options and to remain committed to a single design. External integration tools consist of ways to link the work of the implementation team to users at all organizational levels. Implementation strategy must not only encourage user participation and involvement, but it must also address the issue of counter-implementation. So counter-implementation is a deliberate strategy toward the implementation of an information system or an innovation in an organization. The new system can be made more user-friendly by providing the end-user interface. Designing the organization. Information system projects must explicitly address the ways in which the organization will change when the new system is installed, including installation of intranets, extranets, and web applications. Ergonomics refers to the interaction of the people and machine in the work environment. An organizational impact analysis explains how a proposed system will affect organizational structure, attitudes, decision making, and operation. This table lists the organizational dimension that must be addressed when planning the implementing information system. The employee participation and involvement, job design, standards and performance monitoring, ergonomics, including equipment, user interfaces, and the work environment, employee-driven resolution procedures, health and safety, government regulatory compliance. Socio-technical design. One way of addressing human and organizational issues is to incorporate socio-technical design practices into information system projects. Designers set forth separate sets of technical and social design solutions. The resulting socio-technical design is expected to produce an information system that blends the technical efficiency with the sensitivity to organizational and human needs, leading to higher job satisfaction and productivity. Project management software tools. Project management software typically features capabilities for defining and ordering tasks, assigning resources to tasks, establishing starting and ending dates to tasks, tracking progress, and facilitating modification to tasks and resources. Project management tools assist an individual or team in organizing and managing their projects and tasks effectively. The term usually refers to project management software you can purchase online or even use for free. So ito yung mga software na yan. The Microsoft Office Project 2010, Project Professional 2010, Project Server 2010. So yung Microsoft Office Project 2010 has become the most widely used project management software today. It is PC-based with capabilities for producing PERT and Gantt charts and for supporting critical path analysis, resource allocation, project tracking, and status reporting. So ayan yung ginagamit daw ngayon. Ito naman, projects such as easyproject.net and Vertabase are also useful for firms that want web-based project management tools. Ginagamit din siya, pero web-based siya. Ayun lang po. Thank you po.
Okay, thank you very much for our comprehensive discussions about the topic. Again, in this chapter, we look into the importance of project management. It cite the example of a runaway projects and system failure, and the project management objective. In selecting the projects, we need to understand management structure of information system projects. So as I mentioned earlier, it's too important for us to understand the details, any transactions within the department, linking system projects to the business plan, and identify the critical success factor, portfolio analysis, and we need to use some scoring models. In establishing the business value of information system, the information system cost and benefits must be considered. The real option pricing models and limitation of financial models must be observed. In managing project risk, the dimension of project risk and change management in the concept of implementation, controlling risk factors, designing for the organization and project management software tools must be also considered. Okay, now, a while ago, our presenter mentioned about the scope, the scope of the project. So for us to know if we can complete the system per module, let's say, for example, in your research right now, you are now developing your thesis. So if I am the panels, if I am one of the member of the panels, I just want to find out if you completely accomplish or satisfied the system module. So we look into it. For us to know if we can complete the system per module, we need to know the scope. So your system must adhere to your objectives. Now, let's say, for example, in some other universities and colleges, they don't have a statement of the problem. Instead, objective of the problem or objective of the study. But of course, in some colleges, they are still using statement of the problem, as well as the extent and the limitations of the problem. Again, there is two different terms, limitation and delimitation. Limitation is different from delimitations. Take note of it. Now, Although the triple constraint theory appears to be difficult, it is actually quite simple. Let's begin with an explanation. Now, according to the triple constraint theory of project management, every project is constrained by scope, time, and money. Of course, no? Because a change in one aspect will almost always have an impact on the other two. So it means to say, if there are certain changes with the scope, it will affect the time and money. Right? So if a customer or if your clients wishes to add a bunch of new features to the project scope, let's say for example, you just simply creating web-based information system, then during your defense, no, the panels or even the invited owner of the company requesting to have as an SMS application. So therefore, there is certain change or constraint, specifically with time and money. No? So they'll need to budget additional time and money, as I mentioned. Alternatively, if your supervisor cuts your project budget, you'll have to reduce the project requirements. So to put it another way, it's all about compromises. So it's your responsibility as the project manager to balance these three restrictions and manage expectations so that everyone understands what it takes to complete the project successfully. Let's say, for example, I am not a member of the panel during your chapter 1 to 3. Then I was invited, let's say, for example, during your final defense. So what I'm looking at is the defined scope approved by the previous panel. And I will check it one by one per module if you will be able to accomplish the suggestion. No? Now, the project management triangle is a term that refers to the triple constraint theory. So that the three limitations of project management are represented by each side or point of the triangle. No, the scope, the time, and the money. Now, a while ago, before our presenters start, no, I asked 5 questions. No? So number 1, what are the objectives of project management and why is it so essential in developing information system? Actually, it's very essential. No? Most of the time we are using SDLC, Agile, no, fishbone analysis or fishbone analysis, or and other, no, and any other tools, no, for us to accomplish or to develop our software. No, so project management is critical to ensure that solutions are delivered on time, on budget, and with real commercial value. Planning the task, assessing the risk, estimating and collecting the resources needed to complete the works, organizing the work, directing execution, and analyzing the results are all the example of project management activities. Again, scope, time, money, quality, and risk are the 5 primary issues that project managers must deal with. Question number 2 a while ago. Now, what methods can be used for selecting and evaluating information system projects in aligning them with the firm's business goals? Of course, an information strategy or an information system strategy defines how information technology helps organizations achieve their business goals and documents all of their system applications and IT infrastructure components. Some large organizations will have a management structure in place, no, to guarantee that the most critical system initiative get the attention they need. And it's possible to apply critical success factors, portfolio analysis, and scoring models, alternative information system programs to identify and assess. Number 3 question earlier, how can firm assess the business value of information system projects? Calculate the cost and benefits of an information system projects to see if it is good investment. No? Because tangible advantage can be measured and intangible benefits that can be measured right now may yield quantitative benefits later. So to ensure that a project offers a good return on the firm's invested capital, benefits that surpass expenses should be examined utilizing capital budgeting methodologies. So, when evaluating extremely unpredictable IT investment, real option pricing models which apply the same principle for valuing financial options to system investment can be, of course, effective. Question number 4, what are the principal risk factors in information system projects? Now, the level of risk in a system development project is governed by 3 factors. Again, the project size, the project structure, and technology experience. So, when there is insufficient or improper user participation in the system development process, lack of management support, and poor management of the implementation phases, information system initiatives are more likely to fail because they need applications and mergers and acquisitions have a high failure rate. And the last questions we threw earlier is what strategies are useful for managing project risk and system implementations. Now, the complete process of organizational transformation surrounding the introduction of a new information system is referred to as implementation. Now, support and involvement from users as well as support and control from management, mechanism for dealing with the level risk in each new system project as well as the aspect of the implementations process are critical. So, therefore, a contingency strategy to project management can help bring project risk elements under control, and the proper mix of external integration tools, internal integration tools, formal planning tools, and formal control tools to be used depends on the project risk level. Okay, so I think that's it for this topic.